Fine. All of you listen carefully, not carefully. Even if अरे ऋचा इतना दुखी दुखी क्यों है? नहीं नहीं, हाथ का सपोर्ट मत रखो. Sudden body posture you have to learn for interview purpose. Okay. Anyway, अरे क्या पी रहा साहिल, क्या पिया अभी?
वाटर सर.
चलो ठीक है. With this vibration subject, 1 glass of water is GST. You can keep water, you can keep a cup of tea also if you want, a cup of Bonvita, Horlicks, and finally you must have Mentos. दिमाग की बत्ती जला दे. ठीक है. अब क्या है कि मेंटोस बनाने वाले को मालूम नहीं है कि वाइब्रेशन सब्जेक्ट ऐसा है कि 100 मेंटोस के बाद भी दिमाग की बत्ती फ्यूज रहता है. फाइन. एनीवे, so what I want to tell you right now is that we have just completed 1 month. Tomorrow it will be 5 weeks. So from today we will be switching over to the difficult portion of vibration. So whatever we had last 1 month, that was something like babysitting. Although babysitting is the most difficult task, much more difficult than doing engineering job in industry, but last 1 month was very, very ordinary, extremely ordinary. And from today, we will go into difficult where a lot of mathematics will come up. Number one, lot of mathematics will come up, and number two, my speed will now go up. Fine. Now I will not go line by line. Now, before I begin, let me tell you one thing. One person asked me that question. We had just initiated, let me repeat again, we have just initiated discussion on 2 degree of freedom system, if you remember. Today we will pick up a very interesting example. But before that, the moment we discuss 2 degree of freedom or multi-degree of freedom, there are two things which are important. One is all the natural frequencies. And second one that I have not discussed and I will not discuss this week is MOTSEP. But remember, finally, I will bring MOTSEP also in picture. So 2 degree of freedom, there is something called MOTSEP, which I have not discussed. Someone asked me in the last class that there will be solution. MOTSEPs are nothing but solution vector when the matrix is singular. And what is beauty with the MOTSEP is that we do not have unique solution. We will have infinitely number of solution. So MOTSEP I will bring maybe little later, not now. Right now I am focusing on natural frequencies, how to calculate natural frequency of a 2 degree of freedom system. Because in vibration, primarily natural frequencies are more important. MOTSEPs definitely are important, but primarily, let me repeat again, natural frequencies are important because an engineer always attempts to avoid resonance. Fine. He will always look into the natural frequency and then he will see whether resonance is possible or not possible. Now, MOTSEP we definitely need, but again, let me repeat. So today and tomorrow we will discuss 2 degree of freedom system basically, but again, only the natural frequency part, not the MOTSEP part. Okay. Now, I give you 2-3 minutes if you have any confusion in last 1 week. Somebody was telling me question number 6. कौन था वो?
Yes, sir. Nitesh.
हाँ बोलो, क्वेश्चन नंबर 6. अबे डू यू वांट अ काइंड ऑफ प्रॉब्लम सॉल्विंग एक्स्ट्रा क्लास
Yes, sir.
और यू आर एक्सपर्ट इनफ? नहीं नहीं, ऐसा नहीं बोलना चाहिए. Huh. I was rather expecting you should say we don't need any extra class, even teacher should reduce 4 lectures in a week. That is what I was expecting from you. Okay, so Srabha, your job is I'm ready for only problem solving class, no theory, only problem solving. You find out if Sunday is possible, then you tell me the time. ठीक है?
Okay, sir.
But early,
Sir,
huh? Get
not Sunday, sir. I have
अरे
something family function, sir, please.
अरे फैमिली फंक्शन करो ना, लोग तो शादी के दिन भी हमारा वाइब्रेशन के क्लास अटेंड करते हैं, फिर शादी करने जाते हैं. हाँ?
Because I may not be able to attend class, that's why I'm.
अरे साइड में मोबाइल ऑन करके रख देना. You know, okay, let me tell you this third year. You know Ambati Dhanush? Srabha? Ambati Dhanush, learn from
Yes,
him.
sir.
अंबाती धनुष क्या करता है, वो कभी क्लास अटेंड नहीं करता, वो रास्ते में घूमते रहता है, जहां भी घूमते रहता पेड़ का नीचे बैठ के मोबाइल ऑन कर देता. फाइन. I mean, he is an extremely talented boy. See, and he is from Telangana, somewhere close to Nalagunda. Anyway, ठीक है, संडे को पॉसिबल नहीं है तो ठीक है, बाद में कभी देखेंगे. लेकिन नीतीश को प्रॉब्लम है, बाकी किसी को प्रॉब्लम है संडे को नहीं है. तो अर्ली मॉर्निंग अगर संभव है, वी विल हैव इट. नीतीश इज एमटेक, सो ही डजंट रिक्वायर ए प्रॉब्लम सॉल्विंग क्लास. फाइन. We will go ahead with the problem solving class Sunday because I have lot of job. Gradually I am getting more busy. तो ये मेरे बात सुनना पड़ेगा, but that is extra class. You will not lose attendance even if you remain absent. Richa, are you busy Sunday? You are looking little नहीं ना? संडे का दिन घर में ब्रेकफास्ट बनाने का काम नहीं आता? नहीं आता है. हाँ, साहिल बोलो. You have a problem on Sunday?
No, sir.
Good, good, good. I mean, gradually you will learn that when you will join a job, you will learn that there is no Sunday in the calendar of engineers. Gradually you will learn there is no midnight, because when I used to work in industry, you know, there was no midnight, no evening, nothing like that. If there is a problem, you have to work 24 hours. You can't say कि अभी तो शाम हो गया, भूख लग रहा, घर में गेस्ट आने वाला है, तो वो भी आपको इंडस्ट्री में गेस्ट बना देगा तुरंत. Anyway, ठीक है. So let's begin that phase 2 vibration, which is going to be little more difficult, no doubt. So you just take out a camera and face that phase 2 vibration. चलो कैमरा निकाल लो सब लोग. I will come bring the okay. Now, in my last class, if you remember, picture was same. In the last class, picture was same. Only thing, excitation was absent. So if excitation force also happens to be there, we write them in the equation. Now, whenever I say excitation force is present, it need not be present with all the coordinates. Commonly, we will see excitation is present only in one of the coordinate. But there can be situation when excitation is present with all the coordinates. This is more complicated case where excitation is present in all the coordinates. We will discuss both the examples today. In one case, excitation is present in both the coordinate. In another case, excitation is present in one coordinate. So first let us take up, if excitation is present in both the coordinate, how do we solve the problem? So as an example, I have taken up this. You look at this now. And don't look at the mathematics. Don't look at the mathematics. You only look at the figure. And can you guess what I am talking about?
Automobile.
Mobile, a bike.
Agree. I'm talking about a bike. It may be a car also, but something more than that. Something more than that. Today, what do you see? We have also discussed automobile.
Motion transmissibility in automobile.
Today, correct. If you remember, similar problem we have already solved with one wheel or with two wheel. We have solved a vehicle moving on a wavy road. But in that discussion, how many wheels we had considered? One, because it was a single degree of freedom model. And if you remember, I had mentioned that gradually it will get more complicated. So this is more complicated model because instead of one wheel, we are considering two wheel. One excitation will come from ground in the front wheel. Another excitation will come from the ground from the rear wheel. Now there is a problem. What is the problem? Excitation in the front wheel is not same as excitation on the rear wheel. So if the front wheel is going up by y2, rear wheel will be going up by another value y1. But there is a relationship between y1 and y2. That relationship will depend on this wheelbase. We call it wheelbase. Wheel to wheel distance, we call it wheelbase, d, and the wavelength. So d by lambda is phi. So the displacement in the front wheel and displacement in the rear wheel, they will not be same phase. There will be a phase difference. And that phase difference is, of course, d by lambda into 2 pi. D by lambda into 2 pi. So now we not only have support excitation, they are also not having same phase. But their omega will be same. Why omega will be same? Because velocity is same whether it is front wheel or rear wheel. So omega will be same. Y will be same because the road remains same for both the wheels. Capital Y remains same. Only thing, there is a phase difference phi. So now, if we model, and these are the equation of motion, whether we are getting them with using Lagrange or free body diagram, these are the equation of motion. And finally, I will show you the equation of motion only. Correct. Finally, this is how the equation of motion looks like in the form of matrix. So this is inertia matrix, this is stiffness matrix, and these are the excitation. Okay. So how we solve them, we will discuss. If we can solve them for, now why it is complicated? It is complicated because of two reasons. Force is present, excitation is present in both the coordinates. Second, on each coordinate, we do not have single excitation, we have a pair of excitation. This is excitation number 1, this is excitation number 2. We have a pair of excitation. So if suppose we solve same problem where we don't have second force, even in the first case we have only one force, not the second one. If we can solve it, then we can solve this case also by what is known as method of superposition. I have written it here. Method of response superposition. That means we find out the solution one by one. So there are 4 cases. First we take this excitation, solve it. Next we take this excitation, we solve it. Third, we take this excitation, we solve it. Fourth, we take this excitation, we solve it. So taking one excitation at a time, if we can find out the solution x and theta, finally we sum them up. So that is called superposition principle, where for each excitation we find out the response and finally we take the total. So although it appears to be little complicated, we can still find the solution if we know how to solve it for a single excitation. So that we are going to discuss now, single excitation. But this was an example where excitation was far more complicated. But we can handle it if we can handle it for single excitation case. So next, I'm going to single excitation scenario. Okay. Now listen for 5 minutes carefully. This is an industry problem where we have a horizontal beam at a height. On top of the beam, we have a machine. The machine has an unbalance due to which there is a vertical force F0 sine omega t. Now, this is modeled as a single degree of freedom where K1 is 192 EI by L cube, M1 is mass of the machine, so we know how to calculate the natural frequency. Damping we assume negligible. So my equation of motion is M1 x1 double dot plus K1 x1 is equal to F0 sine omega t. This F0 sine omega t is the force that is coming in the vertical direction because of unbalanced force. Fine. Now, in case this omega happens to be close to omega n, and because damping is small, what will happen? This beam will have large vibration. And it has happened in industry. A machine जो है अपना बोल्ट से निकल के फेंका गया. The machine got uprooted and it got thrown away. People have got injured also. Even I know in an industry where I was working, it happened where I got saved, but my boss, his collarbone got broken because the machine got uprooted. Fine. So these are very dangerous cases where natural frequency matches with the running frequency. Okay. So suppose a civil engineer, he has designed this beam. The civil engineer forgot to know or forgot to ask what is the RPM of this machine. He thought that is the job of mechanical engineer. So he didn't bother. He designed the beam. But it so happened by chance this omega n exactly became close equal to omega. This omega is related to rotating frequency. तो जैसे मशीन चलाया गया पहला दिन, this whole foundation started vibrating, having large amplitude of vibration. Immediately the motor was switched off and a meeting was called. What to do? ठीक है? You imagine you just joined that day in that company and you were a member in the meeting. आप क्या करोगे? Nitesh, what you will do?
Yes, sir.
क्या करोगे? You have joined the company with a very lucrative salary package. 20 lakh दे रहा company. You have joined and you have been called in the meeting that there is a serious problem. जैसे machine चालू किया, the vibration in the beam and the machine is coming out to be very very large. अब कंपनी ने 20 लाख पैकेज दिया तो कुछ तो एक्सपेक्ट करेगा. हाँ बोलो.
Sir, balancing.
बैलेंसिंग आता है?
Not yet, sir.
तुम्हारे कॉलेज में बैलेंसिंग पढ़ाया गया?
Yes, sir. I've studied the balancing.
अरे नहीं, वो तो थ्योरेटिकल बैलेंसिंग, उस पे इंडस्ट्री का बैलेंसिंग कहाँ होता है? टेक्स्ट बुक का बैलेंसिंग इंडस्ट्री में नहीं चलता. ओके, एनीवे, सो बैलेंसिंग इज ठीक है. दैट इज वन आंसर. सेकंड आंसर, एनी अदर स्टूडेंट?
So increase eta.
How? See, this is the thing. You have joined an industry, so you cannot give theoretical answer. Question is how?
So using isolators, I guess.
Immediately your boss will ask, कैसे डैम्पिंग कैसे? Theoretically that is a correct answer. Practically कैसे डैम्पिंग बढ़ाओगे? वो स्टील का है. That beam is made of concrete or steel. So whatever is the material damping, you have to accept it.
So using isolators, can we do that?
आइसोलेटर यहाँ पे नहीं लगाया जा सकता है क्योंकि ओके, आई विल नॉट डिस्कस दैट. एनी अदर सॉल्यूशन कमिंग टू योर माइंड? एनी अदर स्टूडेंट? बैलेंसिंग इज द फर्स्ट करेक्टिव solution, I agree. But remember, balancing is not so simple. And this third year, you have missed my lecture in theory of machine. So you don't know what is balancing. Let me tell you. आपका क्लास में बैलेंसिंग जो पढ़ाया गया वो बेकार है. Okay, that actual balancing that we do in industry is different. Therefore, teachers who have not been in industry, they don't know and they cannot teach. Balancing in industry is difficult. एक बैलेंसिंग में 2-3 लाख रुपए हम लेते हैं. It generally takes 4 to 6 hours. और बैलेंसिंग करने के लिए minimum 1 lakh rupees हम लेते हैं. It is difficult thing. I will not come to that discussion how balancing is to be done. But yes, go for balancing is a correct answer. I accept. But other than that solution, what else?
We can change the excitation frequency.
कैसे करोगे? नितेश, हाँ, कैसे करोगे?
By changing manipulating the current and voltage.
नहीं, योर आंसर हैज टू बी प्रैक्टिकल. मैनिपुलेटिंग मतलब वो मोटर को जाके उसका कान में बता दोगे तो मोटर अपना स्पीड बदल देगा.
The electricity we are providing to the motor, we should decrease it.
Decrease it. This clearly shows that you have not learnt engineering. It's a very, very wrong answer. Can anybody tell me why I am calling it a wrong answer?
Because motor has a rated.
No. Nitesh, you don't suggest and you are answering, you are suggesting. Don't do both. Let other student also participate.
Yes.
See, this shows. Let me tell you, I mean, yesterday I was talking to one of my school friend and I told him that engineering education has vanished from India. Whatever we are teaching in engineering colleges, that is nonsense. Let me tell you, including BNIT, whatever we are teaching in our colleges, that is nonsense. Useless. Because our students are not learning what happens in real life. So, can anybody tell me why this suggestion I am not accepting? Nitesh suggested that he can manipulate speed of the machine. Why I am not accepting it? Let me hear it from other student. You can guess. But it should be an engineering guess. It should not be just a pure guess. There has to be some logic in it.
Because the motor runs at a particular speed, rated speed, and
Why a motor runs at a rated speed?
So because we require that speed.
No. See, this is the problem why present generation students are not getting job in core industry. And then they complain, sir, हमें तो नौकरी नहीं मिल रहा. You are unable to answer even easy question. हाँ, बोलो. I will keep the question alive. This is a very important question. Just a first year engineering student should be able to answer.
sir, it is designed according to the speed.
Why it is designed according to speed? You cannot escape. You are engineer. See, this is a problem you will have in machine design too. This is a serious problem we never discuss in machine design too. In machine design too, most of the times we just assume a particular speed. Remember, in industry, we cannot assume a particular speed. Why? Because if you go to the market, if you buy a motor, you cannot go to the market and buy a motor. अरे मुझे 800 आरपीएम वाला मोटर चाहिए, मुझे 1200 आरपीएम वाला मोटर चाहिए. You go and ask in the market, लोग हंसेगा, बोलेगा कौन सा कॉलेज से इंजीनियरिंग पास किया. कोई बता सकता क्यों लोग हंसेगा?
There is a standardization of
No. This is a very ordinary question. But this is the thing that in our education we do not discuss the actual question of engineering.
motors sold according to their rated power.
एक गड़बड़ कर रहे हो. Power can be different. A motor can be designed for different power. Remember that. If you go to the market, generally वो fractional horsepower बोलता है उसको. घर का अगर पानी उठाने के लिए पंप चलाना है, they are generally in terms of horsepower. You can have a variation in horsepower, but you cannot have a variation in RPM. Why? Why? एंड यू कैनॉट एस्केप कि हम तो मैकेनिकल इंजीनियर हूं, मुझे मोटर के बारे कुछ भी मालूम नहीं है. यू कैनॉट एस्केप इन ए कंपनी यू हैव टू डू ऑल द जॉब योरसेल्फ. मेटलर्जी, इलेक्ट्रिकल, सिविल, मैकेनिकल. रिचा, यू हैव एनी आइडिया अबाउट मोटर? फर्स्ट ईयर में पढ़ाया गया था. अरे भाग गई. She must have left the class. Okay, Aditya.
Yes, sir.
No, and try to answer it. This is a serious question.
Sir, there are some motors called stepper motors.
My goodness, इंडस्ट्री में स्टेपर मोटर यूज नहीं होते हैं. इंडस्ट्री का स्टेपर मोटर्स आर यूज्ड इन डिफरेंट कंटेक्स्ट. इंडस्ट्री मोटर्स आर नॉट स्टेपर मोटर. यही तो गड़बड़ है ना. Can
No,
anybody
sir.
tell me what kind of motors are 99% used in industry? A single kind of motor.
Sir, I don't have
Auxiliary
idea.
motors.
ऑक्सिलरी मोटर हमने तो कभी सुना ही नहीं.
AC motor, sir.
एसी
Sir.
मोटर करके. हाँ.
Sir, I think it is due to the frequency of
Now I am asking a different question. In industry, 99.9% cases, we use only one kind of motor. What is the name of that motor?
Gauge
The
motor.
induction motor.
This is the correct answer. Induction motor. अब यही तुम लोग कुछ भी करेक्ट जवाब नहीं दोगे, उल्टा सीधा जवाब दोगे और फिर बोलोगे सर मुझे 5 लाख का सैलरी चाहिए. 5,000 भी कोई दे देगा नहीं. You don't know. In industry, all the motors are induction motors. In industry, stepper motors are used other cases where power requirement is not high, where control actions are important. But जहां पे सिर्फ घुमाने का काम है, we go for induction motor. But there are other kind of motors. I'm happy that at least somebody has learned the name called stepper motor. There are other kind of motors, stepper motor, servo motor, and last 10 years, another name, whether you know that or not, I don't know, BLDC, brushless DC motor, BLDC motor. ड्रोन में जो मोटर यूज होते, they are all BLDC motor. Fine. So there are other kind of motors which we are using at other specific cases. Stepper motor, servo motor, BLDC motor. But in industry, we use Induction motor. An induction motor, I don't know whether you really know that. In an induction motor, will you answer my question carefully? Speed is, can we have any speed or we can only have some particular speed? कुछ याद आ रहा फर्स्ट ईयर का?
Sir, particular speed range is there.
So can you name some of the speed? कुछ याद आ रहा? No, let me tell you one thing. This is the kind of question industry people ask when they come for interview. And then they go back and say VNIT. I mean, that is the feedback we are getting from industry for VNIT students. कि VNIT के मैकेनिकल इंजीनियरिंग में बच्चे को कुछ भी मालूम नहीं है. They are not wrong. Can anybody tell me induction motor का RPM एक पर्टिकुलर जोन में ही होता है? Can you name 2-3 speed?
The 3600 RPM.
ए देखो, you are not in America, Srabba. 3600 is in America, not in India.
1200.
नहीं, वही तो हो गया ना. प्लीज रिमेम्बर. नहीं, आई एम सॉरी, मुझे कभी कभी लगता है कि ये सबको फर्स्ट ईयर में और 2-3 साल पढ़ाओ.
Sir, for 3-phase 3000.
फिर वही तो हम बोल रहे ना, फर्स्ट ईयर में 3 साल पढ़ा, कुछ भी नहीं सीखते हैं. देयर इज नथिंग लाइक 3 फेज और सिंगल फेज. ऐसा नहीं है कि 3 फेज का आरपीएम अलग होता, सिंगल फेज का आरपीएम अलग होता. ओनली थिंग द इलेक्ट्रिकल टेक्नोलॉजी इज डिफरेंट फॉर 3 फेज एंड सिंगल फेज में हम स्प्लिट फेज में जाते हैं बेसिकली. सो वी नीड अ काइंड ऑफ कैपेसिटर टू स्प्लिट द फेज. बट as far as RPM is concerned, please remember, listen, I mean, I'm really sorry, you don't take it otherwise, कि कुछ भी नहीं सीखा है इंजीनियरिंग का फंडामेंटल्स. इंडक्शन मोटर RPM is close to synchronous speed divided by integer n. Synchronous speed is line frequency speed. So in India, the line frequency is 50 hertz. In America, line frequency is 60 hertz. But in India, 50 hertz. So 50 hertz corresponds to 3000 RPM. In India, all the turbines and generators, all the generators, they must rotate at 3000 RPM in India. All power producing generators, they have to run at 3000 RPM because the line frequency is 50 hertz. So induction motor RPM is always close to this synchronous speed divided by integer. We call it integer means number of pole pairs. So if an induction motor has single pair of pole, its speed will be close to 3000. If 2 pair of poles, its speed will be close to 3000 by 2, that is 1500. If 3 pair of poles, 3000 by 3000. Now it will be close to this speed, but not exactly. There has to be a gap. Then only it can take up the torque. That gap is called slip. So slip is the percentage difference between running speed and the synchronous speed. So synchronous speed is 2 pi f divided by number of pole pair. So if number of pole pair is 2, synchronous speed is 1500. But an induction motor can never run at 1500. It will always run at a speed little less than that. So if it runs at 1470, that means the difference is 2%. We call it slip. Induction motor must have a slip, then only it can deliver a torque. So how much is that slip? It depends on the torque, and therefore there is engineers should know there is something called torque slip characteristics. So torque delivered by induction motor depends on how much is the slip. generally sleep varies between 2 to 4% generally. ऐसा नहीं है कि 1500 सिंक्रोनस स्पीड है और इंडक्शन मोटर 1400 में घूम सकता है, ऐसा नहीं है. So this is the reason why whenever we buy a motor from the market, we cannot ask the motor to run at any speed. या तो मुझे 1500 सिंक्रोनस स्पीड पसंद करना होगा, या तो 1000 में पसंद करना होगा, या तो 750 में पसंद करना होगा. Of course, I have another alternative. I can go for a gearbox. अगर मुझे 1200 में चलाना ही है, okay, I buy a motor of 1500 and then I use a gearbox. ठीक है. However, in this case, there was no gearbox, and by chance, this speed matched with the natural frequency. So let me come back to our problem today. अब क्या करोगे? Excitation frequency you cannot change. Of course, you can change the motor. If the motor was running at 1470, you can go for another motor which is close to 1000. बराबर है, लेकिन ये मोटर को फेंकना भी तो उचित नहीं होगा. We have purchased it. Every motor in industry it costs 10 to 20 lakhs. तो हम क्या करेंगे? Anything coming from your mind?
Rubber pad.
रबर पैड में वाइब्रेशन मशीन का वाइब्रेशन कम नहीं होंगे, आइसोलेशन कम होंगे. आई एग्री, मशीन का वाइब्रेशन कम नहीं होंगे. ओके, लेट अस सी व्हाट वी विल डू.
Sir,
लेट अस सी. हाँ बोलो.
sir, can we change the dimension of the beam, that is cross section?
मतलब इसको तोड़ना पड़ेगा.
Yes, sir.
See, this is the problem of working in industry. Most of our suggestion people will laugh at it. बोलेगा इसको एक बीम तोड़ने से कितना खर्चा होगा और कितना समय लगेगा. 1-2 महीना कुछ भी नहीं होगा. हाँ, the first thing company will do is throw you out from the company. Yes, theoretically suggestion is correct. Can we change the dimension of the beam? Theoretically this is a correct suggestion, but practically इसको तोड़ेंगे के तोड़ के नया बीम डालेंगे, समय लगेगा, खर्चा लगेगा. Okay, so let me discuss it. This is a very interesting problem. At least I have faced in industry many a times, and even when I have gone for consultancy from VNIT, I have faced it. The first solution is, if you know balancing, go for balancing. Second solution, which is not feasible, is change the running frequency. But almost in all cases, you will see you cannot change the running frequency. So that is not a very practical solution. Let me go to third solution. But उसके लिए थोड़ा mathematics जानना जरूरी है. So what I do is, I ask my boss. I have joined the industry. I ask my meeting लंबा चला. Meeting चलते चलते 1 बज गया. 1 बज गया तो your boss said, let's go for a lunch break. So everybody went for lunch break for 1 hour. During the lunch break, you the VNIT student, you do one thing. चुपके से बीम का नीचे में जाके एक हल्का सा स्प्रिंग K2, एक हल्का सा मास M2 लगा दिया. ठीक है. In 1 hour you can do that. You just connected a small spring, not a heavy spring, a small spring K2 and a mass M2, such that K2 by M2 is equal to omega n square. So this you did it in 1 hour lunch gap. So after the lunch gap, everybody comes and then you take your boss कि मैंने कुछ किया, मशीन चलाया जाए. जैसा मशीन चालू किया गया, you know what happened? Complete vibration came out to be 0. Complete vibration came out to be 0. You did something. Nobody knows what you did. But when the machine was started again, the vibration simply vanished. And now you ask for a salary increment. कि अभी मेरा प्रमोशन होना चाहिए और कम से कम 5 लाख बढ़ना चाहिए. ठीक है. So let's see how it happened. So our model where we had only K1, M1, because of this spring, the model becomes 2 degree of freedom, K2 and M2. So this is my model after I have added this spring. This is called auxiliary spring or secondary spring or absorber spring. This is called auxiliary mass or secondary mass or absorber mass. This pair together is called absorber setup. Pair together. A spring K2 with a mass M2, it is called absorber. Fine. So I have added an absorber. So now this becomes 2 degree of freedom. फिर इसका equation of motion. Now you look at the equation of motion. So now you start your pen and paper business. So you agree this is the equation of motion? Because this 2 degree of freedom model, we have done it before. Only thing, now I am adding a force. 2 degree of freedom model, we have used it before. Only thing, I am adding a force now. So this is my equation of motion. लिखो जल्दी से लिखो equation of motion. So draw this picture. Draw this picture. So once I have added an absorber spring and absorber mass, my single degree of freedom model, it becomes a 2 degree of freedom model. Excitation is only with the degree of freedom 1. So this is my equation of motion. Question is how we can solve it. So for solution, we go like this. So this is my 2 equations. So we assume a solution. X1 is capital X1 sine omega t. Small x2 is capital X2 into sine omega t. And we put this solution into the differential equation. So if these expressions can solve these 2 differential equations, then these solutions are acceptable. So let's see whether solutions are acceptable or not. So what do? We put in this equation, we put x1 is capital X1 sin omega t, छोटा x2 is capital X2 sin omega t. फिर हमें a मिलता है, चेक करो a मिलता है कि नहीं. So we get 2 algebraic equation. So our differential equation gets shifted to get transformed to algebraic equations. But to do it, खुद अपना हाथों से उसको देखो ऐसा आ रहा कि नहीं आ रहा है. I'm giving you time, 5 minutes time. If you put this assumed solution into the equilibrium equations, you will get 2 algebraic equations in matrix form. In matrix form. This is a matrix form, but actually 2 algebraic equations. These are algebraic equations. These are not differential equations. These 2 are differential equations. They get transformed to a pair of algebraic equation which can be written in a matrix form like this. And then you apply Cramer's rule. I think all of you know Cramer's rule. Cramer's rule is each unknown. Now this is not homogeneous. This is not homogeneous. So this matrix, the determinant need not be 0, should not be 0. Because this is not homogeneous, solution will exist provided the matrix is non-singular. Matlab determinant is non-zero. In this case, determinant cannot be 0. Fine. So Cramer's rule says that to find out first unknown, we replace first column by right hand side column and then find out the determinant. So d1 by d x1 and d2 by d is x2. So this is Cramer's rule. If you know Cramer's rule, you apply it here, and if you don't know Kramer's rule, leave VNIT. Simple. If you don't know Kramer's rule, I will suggest you leave VNIT. So these results come from Kramer's rule. So if you look at the results, now you find an interesting thing. If K2 by M2 is omega n square, and omega n square was already equal to omega square, so this term becomes 0. And this explains why x1 is coming out to be 0. So this is mathematically, this term explains why capital X1 is coming out to be 0. But capital X2, it will not be 0. X1 will be 0. That means the main motor, it doesn't vibrate. But the absorber mass, it vibrates. And its vibration amplitude is minus F0 by K2. Now, even if the absorber mass vibrates, we are not worried, because if it breaks, we don't lose lakhs of rupees. But if the motor gets uprooted, we lose lakhs of rupees. If the beam breaks, beam is K1. If the supporting beam breaks, we lose lakhs of rupees. Not only lakhs of rupees, we lose several days of production. So it doesn't mean that X2 can be large. We have to see that X2 is also not large, but X1 is perfectly 0. So this technique of completely killing the vibration is called tuned vibration absorber concept, TVA. We call it tuned vibration absorber concept. This is very, very interesting. We use it in industry. Let me repeat again. This whole concept is called tuned dynamic vibration absorber or tuned vibration absorber. I think I'll give you 2-3 minutes to digest and then ask question. I'm expecting question. मैथमेटिकल डेरिवेशन में कहीं पे कुछ डाउट है? मैथमेटिकल वी हैव प्रूव्ड दैट इफ K2 by M2 is equal to omega n square, and because in this case omega n square is omega square, this numerator factor comes out to be 0. If omega n square is not equal to omega square, this will not be 0. And if omega n square is not equal to omega square, I don't have a problem. Why I should go for a vibration absorber? I have a problem because omega n is exactly equal to omega. If omega n is not equal to omega, I don't have a problem. And I will not go for absorber. So absorber is recommended only when omega n matches with omega. Please see that denominator is determinant of the coefficient matrix. So this is the denominator D. Denominator determinant is determinant of the coefficient matrix. This should not be 0, because if this is 0, x1 will be infinity. So this cannot be 0. But suppose, can it be 0? I said this cannot be 0, but do you think that determinant D also can be 0? I don't know why nobody is saying anything. जैसे मैंने बोला कि जॉब मिलना मुश्किल है, everybody got little bit of depressed. Anyway, doesn't matter. Don't worry, because in India, all engineers are like you people. You will get a job. ठीक है? क्योंकि आजकल पूरे देश में ऐसे इंजीनियर बन रहे हैं जिसको कुछ भी मालूम नहीं है. Anyway, now my last question in today's discussion is, I'm saying denominator determinant D cannot be 0. Do you think it cannot be 0 or it can be 0? And if it becomes 0, what will happen? Practical answer, not theoretical answer.
Again, amplitude will rise and then motor will get.
But can it become 0? What I should mean if I say determinant D is 0? What does it mean? What does it mean? If I say denominator determinant is 0, what does it mean? It means something very significant. What is that significant thing?
Vibration having in unison.
No. जिस दिन से जेई चालू हो गया ना, एमसीक्यू वाला जेई चालू हो गया, उस इंडिया का पूरा इंटेलिजेंस गायब हो गया. The fault is 11-12 कोचिंग क्लास. They are the villain. कुछ भी नहीं सिखाते हैं, बच्चों को एडमिशन मिल जाता है. Yeah, we have 2-3 minutes more. Can anybody tell me that denominator determinant is equal to 0? What does it mean?
So x1 and x2 reach tend to infinity. x1 and x2 tend to infinity.
No. Vibration will be infinity because it is in the denominator. But look at last line only. Look at last line. Denominator becoming 0. What does it mean? If the denominator is 0, mathematically vibration will be infinity. I agree.
So
But
that means second degree we have added is not there.
नितेश फिर से रिपीट करो. बट नितेश थोड़ा रुक जाओ. मेरे अंडर ग्रेजुएट स्टूडेंट्स लोग क्या करते हैं मालूम नहीं है. साई सागर, I don't know if I say Sai, there are 4 Sai in the class. Let me ask Shrabha. Shrabha, how do you answer this question?
Sir, 1 minute.
1 minute.
Yes.
In interview, nobody will wait for 1 minute.
Sir, the frequencies of both the masses will be same.
No. Let me go to Richa. Which class में? She has gone away from the class. Aditya,
Sir, no idea, sir.
no idea. Aditya, so you agree that last 2-3 years you people have hardly learnt anything that can be called engineering.
Sir, we are online engineers.
Can't blame online system for everything. Even when we were teaching offline, our students still did not learn anything. Partially the blame goes to the teacher. अब टीचर को मालूम नहीं है तो सिखाएगा कैसे? Anyway, so last 1 minute, I also have another class now. This denominator D0 इसका मतलब क्या है? Can anybody come up? इसका मतलब क्या है?
The spring we added second K2 spring will not be there to begin with. D is 0.
नहीं. Okay, I'll come back tomorrow. We have a class. I will come back here. 24 घंटा मैं दे रहा.
Sir,
D is equal
omega
to
is 1 radian
हाँ
per
बोलो.
Omega is 1 radian per second.
नहीं ऐसा नहीं है. Okay, I'll give the answer today. नहीं तो तुम लोग को लंच आज नहीं मुश्किल है. This D will become 0 for 2 values of omega, and those 2 values are new natural frequencies. My system was single degree of freedom originally. there was single natural frequency, and this was the natural frequency. The moment I have added K2 and M2, it got changed. मेरा सिस्टम बदल गया. इसका कितना नेचुरल फ्रीक्वेंसी होंगे? 2 नेचुरल फ्रीक्वेंसी होंगे, बिकॉज इट हैज बिकम 2 डिग्री ऑफ फ्रीडम. And when I say d is equal to 0, and if I solve for omega, I get those 2 natural frequencies. So now the system will have 2 natural frequencies which are different from the original natural frequency omega n. So if I solve this line is equal to 0, I get those new natural frequencies. So this discussion I will have it tomorrow. आज यहीं पे, but I'm not giving any PPT today. I will finish the discussion tomorrow, then I will give the PPT. ठीक है? चलो, I have a class now. You also have a class. Let me close the class now today. लेकिन इसको हाथ में लिखा है तो ठीक से समझने का कोशिश करो. Tomorrow when you come back, I mean again you don't sit in the class कि कुछ भी दिमाग में नहीं जा रहा. Don't do that. Okay, चलो. ये कहाँ चला गया? You can exit now.